Okay, so hi there, folks. We're now in our next video and the complex fractions and how to simplify them. And we'll have here our next and final example. I'll give more examples if I can. It depends on the time, but yeah. So this is our last example as far as our book is concerned. So we have here some big and kind of complex fraction as we can as our title suggests. So we have 1 all over 1 minus 1 over 1 minus 1 over x. So what is this? For us not to get confused. So this is the overall numerator. Let's call this n. This is our overall denominator. Okay, so let's call this d. In our denominator, it has one mini another denominator. Let's call this, what do you want? D sub 1, shall we say? And in our d sub 1, we have another denominator. Let's call this d sub 2. Okay, so the sub 1 sub 2 is simply my name for it. So some books will not necessarily name them, but just be aware that this is our main denominator. This is our second denominator under the main denominator, and then we have the d sub 2, which is under the d sub 1, which is all under the same denominator. In essence, we have two denominators under our main denominator. Let's simplify that if it's kind of difficult to understand, but let's simplify this one. What we want to do is just simplify our main denominator to make it a simple fraction, actually. And let's do that here. And let's try to fix our d sub 1 using our d sub 2 here. So how about let's name this d sub 1. How do we fix our d sub 1? Just think of our d sub 1 to be 1 minus 1 over x. Okay? 1 minus, let's fix that. 1 over x. 1 minus 1 over x. So we want to make this denominator here over a single fraction to make it a simple fraction, and put them in a single denominator. So we need first to find the LCD. The LCD, imagine this one to be 1 over 1. And we have x as our LCD since 1 times x. There's no common denominator, so 1 times x is x. So x divided by 1 is still x. X times 1 is going to give us x. If you want x times 1, let's not write that anymore. X times 1 minus 1, and they are again all over x right now. So this is our d sub 1 now. So this is our d sub 1. So x minus 1 over x. So if you want to rewrite it, this must look like our denominator must look like, or our whole fraction must look like this. So 1 all over 1 minus 1 all over. So our d sub 1 is going to be like this. So what we have is our answer is this one. So we're going to put this answer. Okay, we're going to put this answer here in our d sub 1. So in lieu to our d sub 1, this is going to be our new d sub 1. So it's simplified. It's a simple fraction. It is not by parts fraction, but it's a single fraction, which makes things better. We'll have x minus 1 over x. Now, we need to fix this overall denominator of ours. This is our d, our overall denominator, and make them a simple fraction. But first, I think we need to fix this part here before fixing that up. We need to simplify this part first, which is a part of our main denominator. Let's fix that first and make it a simple fraction, since we can see that this is a complex fraction. So let's simplify it. I need more space. Um, yeah, I think that's pretty much can be seen. So let's do that over here. So we will fix this one. Say let's call this d star, shall we? Or not d star. Let's call this d prime. So this is our going to be our d prime. Again, this is for the sake of naming only. D prime. So this is our d prime. So let's fix our d prime. And our d prime can be fixed like this. So we're going, our rules in complex fraction is we need to divide it. So it looks like 1 all over x minus 1. This is minus all over x. So again, this can be rewritten as the equal sign here. So divided by 1 divided by x minus 1. Oops. We have x minus 1, x minus 1 all over x. And then by the rules in dividing fractions, we will need to get the reciprocal of this divisor here, and multiply it with our dividend, which is 1. So if we will do that, what we have actually is 1 times, now multiplying, the reciprocal of this is just x all over x minus 1. And this is by the identity property of multiplication. Any number multiplied by 1 is still the number itself. So this is just equal to x. Oops. This is just equal to x all over x minus 1. Okay, so this is our d prime. So now it's a simplified fraction. Instead of writing 1 all over x minus 1 over x, we just need to write um, d, or rather x all over x minus 1. So let's try to box that so that we won't get lost. Okay, so this is our d prime again. So let's call this d prime. This is our new d prime. D prime. Okay, so let's rewrite the fraction using the new d prime that we have. So let's write it 1 all over 1 minus. Let me write that. Let me write that. Okay, so using the d prime, the new d prime, what we have is 1 all over 1 minus this new d prime. We have x all over x minus 1. So it's a simple fraction right now, not a complex one. And this is the time where we can simplify our d, our main denominator. We can simplify it right now. And okay, so let's put a separate thing for that. Okay, so for the d, so how do we simplify the d? Let's write it 1 minus x all over x minus 1. Okay, x minus 1. So let's find the LCD of 1. You can imagine 1 is 1 over 1. So I think you know that already. The LCD is x minus 1, since x minus 1 times 1 is just simply by multiplication property, identity property. So our LCD will be x minus 1. So x minus 1 divided by 1 is still x minus 1. X minus 1 times 1 is going to give us x minus 1 times this numerator here, which is, equal to 1. Let's just put that so that we won't get lost. Minus x. And I put them already in a single denominator, single fraction, so that that will be our next step actually. So we can see here, if we want to simplify this, actually I'm missing something here. Okay, so let's simplify this. This will give us then um x minus 1 minus x all over x minus 1. So what is x minus 1 minus x? So you can see that x minus x, okay, x minus x is going to give us 0, or yeah, x minus x is going to give us 0. So this can be simplified as, okay, negative 1 all over x minus 1, x minus 1. Or if you want, this can be rewritten as, negative negative 1 all over x minus 1. So I just put the negative sign outside. It's just the same. So this is our main d, our main denominator. What we will need to do is to put this main denominator in our fraction. Let me box this so that we won't get lost again. It's normal for us to get lost, especially if this is your first time to deal something with complex fractions. The main thing is you should not get lost. Okay, the moment you will get lost, it will mess everything up. Okay, and this is our main denominator. Again, this is our original denominator here, 1 all over 1 minus x all over x minus 1. So we fix this one. We fix this into this. So just imagine our numerator as 1. Our simple numerator is just simply 1. So we write that as our new denominator. This will give us going back to our original fraction. So we have 1 all over negative 1 over x minus 1. Okay, and let's proceed now to division, because we can rewrite this as 1 divided by, okay, negative 1 all over x minus 1. And then by the rules of division of fractions, let's get the reciprocal of the divisor, which I mean here is our divisor, get the reciprocal, and then proceed to multiplication. So if we do that, this will give us 1 times the reciprocal of this is negative x minus 1 all over 1. Okay, and then any number multiplied by 1 is still the number itself. So what we have is negative x minus 1 all over 1. Another concept, any number divided by 1 is still the number itself. It's just simply the opposite of the identity property of multiplication. Actually, it is in other words, still the identity property. So x minus 1 divided by 1 is going to give us x minus 1. But don't forget the negative sign outside. So x minus 1. Okay. So I think we need to simplify by distributing the negative sign. So what we have is distribute by distribution property. So distribute this to both terms. So what we have is negative x, negative 1 times 1 is positive 1. And furthermore, to fix this up, it's kind of um not good to look at the first term as negative, though it's okay, but it's kind of proper to make the first term positive. So since 1 is positive, let's make it 1 minus x. Okay, so this is our answer for our complex fraction second example. Okay, so 1 minus x. This is our answer. Okay, so I think you can imagine from our first part. Let me scroll up a bit. Scroll up all the way up, and I just want to let you see what we started up with. We started with this fraction over here. Oops, sorry. Okay, we started with this fraction over here. This one, 1 all over. We started with this fraction. Let me change the color so highlight. So we started with 1 all over 1 minus 1 over 1 minus 1 over x. Kind of complex. Again, we have named some denominators. We have named this the d, and we want to simplify this. This is our main d. We named it d sub 1. We have d sub 2. So we have a lot of denominators within this main denominator here. And then in the last part, we just simply saw that our well, eventually the simplification of this complex fraction is just 1 minus x. Okay, just 1 minus x. Okay, so that's how we simplify complex fractions to make it simple, and how to tackle them, how to solve for them, and that complex fraction became 1 minus x in the end. So which is pretty much better, way better than the first original one. Okay, so that's it for this video. Thank you very much for watching. I hope you learned something from this. And yeah, catch you up with more videos. Don't forget to like this video and subscribe to my channel to learn more about mathematics and complex fractions. Well, thank you very much.